Shading in LookDev in Seneferu's procedural pipeline. Now let's have a look at some of the other techniques that is available during the texturing. This model, as you see, this is not corruption actually. What you are seeing is a per vertex scalar. So the shader assigned to this, which is the generic shader, is having, and most of the shaders actually are utilizing the per vertex scalar in the shading network. So sometimes you can paint on the model before you publish the model, and you can assign, for example, per vertex scalar, and you can paint some color variations or whatever on the model itself. Then this will be utilized in the shading network. If you are using RenderMan, not Arnold, so yeah, you will have to click on this button, which will enable the right of, which will set the map name actually, and also will enable the RenderMan export per vertex colors. So where is the, yeah, it will emit color sets. So if you render this now, you will see that these colors are applied here. These blacks that is painted here is applied on the wood here, and this whole red color here is per vertex painted color. There is no textures at all. It's just some dirt texture, and it's colorized with this red color varying. So just this is just, of course, something very rough, just to show you what that is. Now let's see a little bit more advanced situation where you might have something like this source asset, where you need to have multiple textures for the same asset. Let's say, for example, that this asset is going to be used in the shots multiple times. So you don't want each one of them to be having the same exact texture. In such situations, we have some shaders that are having varying at the end of them. In addition to that, you can use, of course, the color varying based on the if you are doing instances or something. But in this case, this asset is going to be rigged, or it's actually a rigged task, and it will be animated in the shots. So you might be having 10 horsemen in the shot, and you don't want every one of them having the same texture. For this purpose, we can use a shader here called generic varying, and for this kind of short fairy objects, we have something called fairy skin here that you can resolve this shader. And let's do the rest of the assets first. I will assign a letter to everything here except the knots. Actually, even these are leather. We only need, I will actually assign leather for all, then I will selectively do the metal. Let's set matte on this, and let's set these to metal. set tag. And by the way, during the modeling, if these are already tagged, this also helps. So let me see, this is now letter, and I think that some objects are already having tags. No, they don't. Okay, so as we said, the body already. And we want this to be here. Exterior cornea. By the way, the cornea shader and the iris shaders are utilizing the feature of the manifold walk to do some nice caustics on the objects, but it requires that you render with Pixar Unified and to enable the manifold walk. This will make nice caustics on the eyes. This is for all the characters actually. It's always enabled in the cornea shaders. Cornea shader and the iris shader is working as a receiver for this manifold walk. So one is emitting and one is receiving. Also the caustic glass and caustic casting and caustic receiver materials are having the same features. You can always go to the shader and you can read here. There will be always documentation about anything you need to know about a particular shader. So let's finish this now. Eyes internal, we will set this to iris. And we will set this to skin. Yeah, that's it for now. These are metals. These are also metal, and leather. Okay, so let's resolve the whole scene and see what do we have here. Okay, now we have the shaders. Let's do render. That's how the asset looks like without any textures. Don't bother yourself about this varying shader. It's meant to have tough colors so you can catch anything that has anything wrong. And because in the variation there are just bright saturated colors on each option. This varying shader actually can have, let's stop this. And let's start now assigning some textures. Let's see how this shader looks like first. this shader has 4 possible diffuse connected together, and it's in render time, one of them will be selected randomly for each instance of the asset. And each instance of the asset will have, according to the number of the instance, the selected texture for this asset will be consistent from shot to shot. So it's random when it's selected for the first time, but as long as this is called horse 1, it will always have this selected texture to make it consistent from shot to shot, so you don't get the horse texture change on cuts. So what you will do now is exactly what we did before, but in this time we will assign 4 different diffuse, maybe 4 different normals if we have, or bumps, and if the displacements are different also, but I think I made only 1 displacement option, assuming that you will not need, no, actually I did 4 also. So you will assign any displacement, bump maps, normals, whatever you need. So, but make sure that one texture 1 is 1, displacement 1 is for 1, and so on. So you don't get the displacement of texture 1 in the texture 4, for example. So I will assign some textures and we'll come back again. This is how the leather shader looks like even without texture. It could be okay for any secondary or background assets. Without any textures, it might be okay. Maybe it needs some bump maps or displacement, and then it can work just as that. But let's see the horse itself, which is our interest here. So let's see now how the texture varying works. So the way how we selectively choose the random texture on the object instance is based on an attribute called vari_id. This is just a prefix to tell the renderer that this is a primitive variable. So if we make an IPR now, I will show you how this is going to randomly select between the available textures that I assigned. If you have more than 4, you can assign or you can expand the network to more, for example, to 12 textures or whatever. Then you can select from between them. 1.2, 0.3, each number will select a different texture, and also the same color variation in addition to the texture variation itself. So if it happens that you have all these instances of the asset, you can click on Shader Resolve and select all the asset and click on Commit Texture. Now, when you do that, this is actually setting the proper texture directory if you have already texture published for that. In addition, it will set a different vari_id on each instance of the assets. Notice that this number is coming from the asset number. And this, for example, if it's asset number 7, then it will have vari ID 7. This 0.7 is used as a seed for the random function that brings the random texture on the asset in render time. Accordingly, as long as this asset called number 7, it will always have consistent texture. So the texture that is picked randomly for this asset will remain the same during the whole show as long as you load it as number 7. So it will be consistent from shot to shot according to this number, which means that you do not, you should not ever change the number after you have already loaded the asset. Otherwise, you will have to set this number manually rather than using the automated method that I used here. So let's render this and see how it looks like. Notice here that we have some variations, and as I mentioned before, you will notice that some of the repeated texture are having just minor differences. You can increase it, of course, in the shading network, and you can add more variations. Maybe you can have, in such case, maybe you can have more texture than 4 textures as I used now just for this test. So, and this way the rigger actually can also give a control in the rig where the artist can selectively, or the animator can selectively switch between multiple textures. So for example, if in the first shot you have 12 horses, in the second shot you have only one of the horses, instead of relying on the asset instance number, you can have a control in the rig where you can select which exact horse you want, or whatever the purpose is. Such control that can drive the value of the vari ID here will be a nice thing to have in the horse rig, or in a similar asset, of course. As you can see here that with only 4 textures, we have nice color variations between all the instances. And as you can see that even when 3 are having the same texture, they still have color variations in addition to the random textures. So this guy and this guy having the same texture, but see how the difference in the colors are. So yeah, that's it. So of course, if you have also a control in the rig itself, then you can selectively switch between different color variations depending on the needs. Finally, to publish the task, notice that this is horse texture CHR, which means that it's the texture only for the model CHR. So you have these 2 assets here, yes, but this texture task belongs only to this. So you will create the asset locator only for this. It doesn't harm anybody if you created the asset task for all of them, if it's like that, but this means that you are going to publish the texture of these things in this context, which is not going to be used anywhere, because these has to have, each one of the assets has to have its own texture published. So it's not useful to keep these inside the same asset locator. So like that, then you publish. Because if you watch the breakdown videos, you will understand that the subcontext is super important. So as you can see here, I published the texture CHR for the horse bodies, and the texture CHR saddle for the saddle, and the texture CHR reins for the reins. The reason why you have to do this, because we already have divided our asset into multiple tasks, where each one of them has its own subcontext. Accordingly, Seneferu needs to know which texture task belongs to which model task. To do that, the subcontext you added on the model should be added on the texture or any other related subcontext. Otherwise, Seneferu will treat them all as dependency for the same thing, which is not the right thing to do, because later when you resolve the shaders and textures for model CHR saddle, Seneferu will look for lookdev saddle or texture saddle to know what are the textures. If he didn't find such task, then these models will never be, the texture of them and shaders of them will never be resolved properly. Accordingly, you notice that the subcontexts are super important, and if you notice that, or if you detected that the asset manager has created any wrong naming on this or typo on the subcontext, you need to let them know to fix that before you publish. Finally, let's see how to deal with loop variants. Seneferu has two types of variants. If you watch the breakdown videos and the modeling videos, you will find that we covered the geometry variants in the modeling process. Now let's see how to texture these variants. We have already published a texture for this bus. This is just it's taken the bus model, and it's just normally as you saw before. We will just tag the objects and assign the textures and publish that. But when it's time to publish a variant like this, notice that the variant always starts by the dash or this hyphen. This hyphen means that what comes after this hyphen is a variant to the same task, which is in this case is the texture. This could be, for example, texture/body, which means that the body is subcontext. So texture/body dash sweat. This means that texture process for the body, but it's a variant for the body that is sweat. If there is no subcontext and we have only the variant coming directly after the process name, then this means that we didn't have subcontext, but we directly have variant for the main process itself. So let's load dependencies for this process. When you do load dependencies, Seneferu will load the texture, and will do that automatically. If he will do the texture scene that you did for the bus, assuming that a lot of the textures and shaders will be the same, but you will start applying some variants. In addition to this, he will also load for you all the models that you may need during this process. Our model of interest here, of course, is as long as this is texture damage A, then we are interested about the model of damage A. Sometimes you don't have this model. It could be just a look variant without geometry variant too. So it could be, imagine that sometimes this task will not be there. It will be only the same bus model which we have textured here. So in that case, you will publish according to this. But because we have the model damage A, then this is the one that we are going to use to publish the variant. So this is there, but we can hide it. Then what we are going to do is that we will start tag the objects here and resolve the shaders on them. And when you finish, as usual, you will click on Asset Locator, which is having the model damage A, and you will click on Publish. So once you do that, you will get the final result. I will publish these things and I will show them when I finish assigning the textures. Okay, so I published the two variants here, where I have this, which looks like, let's load the light, and this looks like that. So this is variant A, and of course all what I did is that I created the asset locator for model A damage, and I assigned the texture maps to the shaders and published nothing special or different than what we used to do. So now if, for example, if we load, just ignore the texture tasks, let's load the raw models and see the three together to see how each one of them is going to look like when loaded separately in a scene assembly for lighting or whatever. These are now models without any textures or shaders. We will resolve the shaders, of course, and render. Actually, what happens in Katana that these variants are loaded differently based on the shot using something in the task control in Katana, where you can select the asset and switch between the available variants in the database. So these are the variants that we have available here. You can, as long as when we are in production, when we are assembling the scene, we know which asset of these we want in the scene. So as long as this model variant is loaded, it automatically will get the shading of this variant. There is another method that you can use to apply the look of this asset to the geometry of this asset. So you can, in other words, you can have this asset, but you can apply only the look variant rather than applying both geometry and look variant. Publishing look files. As we mentioned before, you can publish a collection of shaders as a look for a specific asset. This collection of shaders that is not part of the shader library, or could be some shaders from the shader library that is tweaked specially for this particular asset and published together as a collection of shaders and textures belonging to this particular asset that doesn't get affected by any updates or modifications to the shader library. In addition, you can publish multiple versions of this look or the look of this character. So you can switch between look variants in different scenarios. Like, for example, if you have the look will get wet by some water in one of the shots, then you can have, for example, look file for the shot for the character as he is, and another look file variant when he's dirty or wet or sweat or whatever. Of course, you can also use the variants that we mentioned before, but this is another alternative in case if you have one look file that shades and makes the look of the whole asset. So let's work on something like this for this asset now. The first thing we will do is to, of course, set the task to in progress, then load dependencies. The load dependencies, of course, will load all the dependencies you need to do your task. And here we have the characters, the character and the garment coming from the it's coming from here, doesn't matter from where. It's because if it's found in the texture, it will be ignored from outside. If it's found there or here, the production manager will load for you the texture, assuming that you are going to use the look that you had before during the texturing to tweak it and to make the final look. But I will assume that the texture isn't there because I don't want to work with the textures now. I want to make just a very simple look by building simple shading network, just to show you how things is working. I will create a simple shader here. Let's say that this will look like this, and we will assign this to this, and let's make another shader. And we will make it like that. Notice that to get this visible in the viewport, you will need to same for this. And assign it. Okay, so let's say that this is what we have, and let's publish the look file of this. It doesn't matter what is loaded, the system will know that this object belongs to the garment, and also he will know that this object belongs to the model. So don't bother yourself that this is the hair groom. Otherwise, you can load the models themselves directly as dependencies for the look dev, as how they can also come to you. So I will select this and I will create the asset locator and publish the look. Proceed. Let's say that this is the look that we want, and Now this is asking you because you are doing a look, final look for your character. So Seneferu is suggesting that if you want to render a turntable or something for the first, middle, and last frame by submitting preview render to the farm or submit to render. Submit to render will render the whole timeline to the farm for the preview purpose, and after the render is done, Seneferu will automatically publish this to the look file for reviewing purposes. Of course, all this publishing action is configured in the processes control table that can be modified and configured here, because any process that can submit something to the farm, you can, or whatever you want to do, you can configure publishing actions to that the system can ask you to run them or to tweak them during the publish. Anyway, this is beyond the scope of what we are doing now, so for this, at this time, I will say just publish. This is now writing the look file. The look file, by the way, having an extension called MA-LKF, which is Maya look file. This look file is a collection of all the shading networks and textures that we made and published during this process. Assuming that we have attached some textures to the shaders that we developed now, then all these will be published together to the look file or to the look dev task, and the look file will have all the information about the shaders and textures that belongs to this character. Now, if these subjects are let's load. If this asset is loaded in the future for any other scene or for lighting or in any other scene, whenever it's mentioned, then when we click on the look resolve, then as you see, now the character is having the shading networks that we published for the look. So these are the shaders that we made for this character. So that was how to create a look dev or a look file for a specific character. Although I still recommend that you stick with the shader library method as long as you can achieve whatever you want using that method, because even if in this particular case we have the skin, you can attach whatever textures you want. You can attach whatever textures you want here, and if you made any minor changes to the shader, then this will not affect any shading component that already have texture during the publish, which makes the look of your character safe anyway. But if you still think that you really need one look file as a collection of shaders for specific character, then of course you can go for it. And by the way, you can use the look file variants as you used the texture variants before. You can publish multiple look variants and utilize them in different situations where you can load different look files on different situations, like when the characters, for example, is wet, sweat, dirty, burned, whatever. And by the way, having look file doesn't deny you from using the material, the shader resolve that you used before. If you have already materials like what we have here, you can still use the shader resolve to resolve your scene, and this will bring the original look of the character rather than the one that you made with the loop file. So see the differences here. Now this is having this shader and this shader, and if you use the shader resolve, this will get you the original shader library shaders that you have tagged before. But if you didn't have tags before, of course this is not going to work.